The primary use case for a nested for loop is for inspecting values of a matrix or assigning values to different elements in a matrix. Previously, we've used this nested for loop structure, but what's new here is this notation. Here we have a valid variable name, and parentheses aren't allowed in variable names. And what this is really doing is saying assign to a matrix, row I, column j, the value of I. Now we'll cover matrices more in detail later, and you'll get a feel for what they do and how they work by going through this example. And so just let me copy and paste this just to see what it does. Copied and pasted this code. It's waiting for me to hit enter. I do. And what's happened is it's created a matrix with 3 rows and 3 columns. And I can use my shorthand to longhand notation to figure out what was happening. Here is the shorthand version, and the longhand version will be this. I have I is equal to 1, I is equal to 2, I is equal to 3, and then I got to repeat this. And now these two programs are the same. And I want to expand out this for loop now. So I need to do 3 steps of j. J is equal to 1, j is equal to 2, j is equal to 3. And this is the repeated part. And I'll get rid of this. And now I'll copy this. Here we go. Now I'll just tell you what this is doing, and again when we cover matrices it'll be covered in more depth. What this does is assign to a matrix named M, capital M, a value I at column J, row I. And so what this is doing is the equivalent of M 1, 1 is equal to 1. This is doing M of 1, 2 is equal to I, and the last value of I was 1. And here we're doing M of 1, 3 is equal to 1. And as before, let's just take a look at what's happening step by step. Copy this first part, and then paste it into MATLAB. And what you can see is this is the first statement for which it printed information. It said, okay, you create a matrix with 1 row and 1 column and assign it the value of 1. When you entered this statement, it said, now you want 2 columns, and the second column should have a value of 1, and it created that. And then here we did the same thing, and you can imagine if I did M of 1, 4 equal to 29, now it's going to tell me I have 4 columns, the last value of which is the number 29. And so that's how you create a matrix and populate elements of a matrix with numbers. So I can watch the whole process take place here. So here I have 6 statements that do not have a semicolon at the end, and so it's going to tell me what the matrix M is at each step. So there's 9 different steps here. At the first step it said you have a 1 by 1 matrix, now you have a 1 by 2 matrix, 1 by 3, and now here's something interesting happens. At that 4th step you've said assign the value 2 to the matrix M in its row 2, column 1, which is this position. But MATLAB says, well, you have a matrix and you haven't told me what to put into here. And matrices, by definition, have to be rectangular. A matrix, if there was just nothing here, it's not really a matrix. And so it just assumes values of 0. I'll show you an example of that in a second. So here now we've assigned the second column, second row, the value of 2. We still haven't told them what this is. And the next step we do. And then here we've assigned the third row, first column of value, and we haven't talked about the other columns. And then here is the ninth step. So it's 3 by 3 matrix, 9 total elements, and we made 9 statements about a matrix. I'll give you another example of creating a matrix. So previously we did something like m of 1 comma 1 is equal to 10. I'll call it 10. Now suppose I do m of 5 comma 5 is equal to 99. MATLAB says, well, you now want a matrix that's 5 rows and 5 columns, at least, in size, and you want that value to be 99. And it doesn't know what to put in the other elements of the matrix, and so it just assumes that they're 0. To clear that, I can create a matrix called D of 5 comma 5. So I've not talked about D previously. I cleared all the variables. So if I do D of 5 comma 5 is equal to 88, it's going to create a matrix with 5 rows and 5 columns, and everything is 0 except that last value, that last element. Now let's go back to the purpose of matrices, which is to is typically that we'll want to visualize the elements of a matrix. So this is just a quick demo of what some of the things you'll be able to do now. Copy this here, and we'll talk a little bit later about a special function called ImageSC. And we'll also talk about what a function is. For now, just assume that a function takes a matrix in parentheses like this, and then it does something. And so what we'll be doing later on is typing commands like this, which is asking MATLAB to plot the matrix M in a colorful way. Plot it as a 2D graph. And here it is. Let's take a look. We have a blue line that's uniform across, a green line, and a red line, which is, of course, the flag of Albania. Let me pop this window down here, expand this out, close this, I'll get rid of this. Let's see what happens if I change that middle value of the matrix. M of 2 comma 2 is equal to, in this case I'll change it to the value of 1. Now if I ask it to plot that image again, plot that matrix as an image again, you can see it's modified this middle value. And so you can probably imagine now that many photo processing programs work by manipulating a matrix. Essentially, an image is a set of pixels arranged on a grid, and each pixel can be thought of as a matrix element. And if you want to change the colors of a picture, you have to modify each element of that matrix or each pixel in that picture to a different value. And in programming, we'll find that an image is essentially represented by a bunch of numbers. So if you see a black and white image, the numbers associated with that could be the numbers 0 and 1, as we did previously with the program on digitization. And if you want to use colors, you have to use a different set of numbers. You can't just use 0 and 1. You need a larger set of numbers to represent a larger set of colors.